Last week, Steve showed you our new hydronic system layout. And in this video, we are going to cover how the assemblies are created and the key components that provide heating throughout the camper, the tanks, and the battery box using coolant from coolant heaters and the engine. And also a new water tank system, which will be heated either through engine coolant or with our coolant heater.
This installation includes fabrication of some sub-assemblies, and because it was such a constrained space, I tried to make sure that as much fabrication was done in the shop and installed as possible. So you'll see the calorifier go in first underneath of the truck. You'll see the installation of the coolant heater in the wet bay, which required me to strip out all the stuff that was in there previously, and also installation of the hydronic floor tubing underneath of the ductboard flooring. I've also built a couple of fan coils that are installed underneath the kitchen counter and end up in the bunk area. And there is a considerable amount of wiring also included in this, which is not shown.
What you got there, dear?
New present.
Oh man, that's huge. Oops, almost tripped over something on the floor. Hey, we're going way over here to the messy table.
Yeah, space here.
Alright, so let's look at this box. So this came all the way over from the UK. And can you guess what it is?
It even says 20-liter single coil horizontal, no immersion.
So we don't know if we got the right part after waiting for how long? 2 weeks?
More like 3.
And if it's not the right part, we don't have time to get the right part.
Make them send the right part to me and put it in. Yeah, so this definitely is a bigger box. Definitely is not very good packaging job. Everything is.
He was worried because the size of the box that it was the wrong tank, but
Big, yeah, a heater, AC heater coil in it. So this has.
Let's take a look.
These two ports here are for the hot coolant to go in and back out. This port here is for cold water to go in, and it has a cold water that goes over to the mixing valve, because the mixing valve is bent. Well, it will if I attempt to. Cold water comes in here, and hot water comes out of here, and mixed water comes out of here. This is a water heater that has 2 sources of heat: 120 volt electrical power and coolant, which could be coming from either the engine or from our diesel coolant heater. It was called a calorifier, and a calorifier is typically the yachting term for this, where the yachting guys use engine coolant to heat hot water because they typically don't have a lot of AC power without running the generator. So this is what the boat guys use to ensure that they can have hot water when they arrive at their destination, which is exactly what I'm going to use it for as well. So our current water heater is 2.5 gallons, and we heat 2.5 gallons to 125 degrees, and that was designed to be and is just barely enough water for us to take 2 showers. It doesn't really even provide, and it provides a little warm water after the fact that we can use to wash dishes. So this is over twice as large in its capacity. This tank is also going to reside bolted to the underside of the cab, not inside my wet bay, so I can get some more space back from my wet bay in order to mount my diesel coolant heater.
He's so excited. He's going to show me all his goodies.
So this is our diesel coolant heater. This is a 5 kilowatt Chinese copy of SPAR D5. This is the water pump that moves the water. These are the 2 water ports on the heater. And this is the exhaust port, and this is the air intake port. No, I got that backwards. This is the exhaust port, this is the air intake port, this is the fuel port. And so this mounts inside of the wet bay. This mounts against the wall so the exhaust port can go outside. It'll probably mount something like this. And these two water ports, this pump circulates water through this thing as it runs, and it heats the water to 180 degrees Fahrenheit. And it heats coolant meaning antifreeze, heats antifreeze. And that antifreeze is circulated through these two horizontal ports of the calorifier. And it's just got a large copper, it goes down and it has a corkscrew inside to make sure it has lots of contact between the copper pipe and the water to heat water. Here we are under the passenger side of the truck. This section here is the control section. If you see on your left hand side here, you'll see the end of the 20-liter SureCal calorifier, which is a hot water tank with a coolant heating coil inside of it. If you look in the schematic, you'll see a section where the end of the calorifier controls are. This is what it now looks like. It's all completely hooked up. The red hose here is coolant supply. The black hose, which is farther up behind it here, is coolant return. The red PEX line is hot water supply. The blue PEX line is cold water supply. The gray cable here is 120 volt power to the 1000 watt immersion heater inside of it. Over here is a junction box where there's 3 valves and 1 temperature sensor here that all collect in here, and this is a 9 conductor cable that goes into the control center. These blue boxes here are the control motors for the electric valves. There is 3 electric valves here. We have 2, one here and one here, which are the engine valves. This closes the supply and closes the return. All the rest of my heating system only uses closing the supply side. So this is the tank valve here that closes the access to the tank. All these fittings that you'll see here, these are all Propex polyphenol sulfone fittings. Chose to use plastic almost everywhere for weight savings. So one of the things I've had to deal with here is this is a 3/4 inch heater hose and this is a 5/8 inch heater hose. The calorifier came with 5/8 connections. My truck has 3/4 connections and I wanted to use 3/4 inch piping throughout. So the threaded connection here is a Propex 3/4 and this is a crimp 3/4. So a crimp 3/4 fits just perfectly inside of a 5/8 and a Propex 3/4 fits perfectly inside of a 3/4. That's what we have. On the calorifier itself, I've had to replace the check valve that it came with because the fittings that it came with were not something that I could connect to. So this is a check valve to provide water flow into and only into the calorifier. And this is the temperature and pressure relief valve, which I put an elbow on to let it vent straight down as opposed to spraying all over everything. About ready to tie all this up. This little project here is a copper radiator to be used with my hydronic heating system in the shower area. This radiator is 16 inches wide, 40 inches tall. And the way that it works is there's going to be a wall right here. And on this side of the wall, you can see the pipe fittings. This is the control column that goes throughout the height of the camper, and this is where the water will have a right angle connector on here and PEX tubing connect to this. So this is the bottom side here, and the way that this is going to work is water will enter here and it will cross across here and go back and forth through here and all the way up to here, and it will go out here. In order to make that happen,
I can't simply leave the water to flow its natural path. If I did, what it would do is it would come in here, it would go straight up here and straight out here. It will never flow through the radiator. What I'm having to do is I'm going to create 3/4 inch copper plate that fits into these spots here and here and here and here and here and here, so that it forces it to flow back and forth. It leaves it to be the only path that the water can flow. What I've done here is I've taken a piece of 3/4 inch type L pipe, I've cut it open and pounded it flat, and now I'm going to have to cut 7 discs out of it. And what I'm going to do is when I join these things in places where I want the water to be redirected, this disc will fit inside the joint. The other thing I'm trying to do is I want to make sure that if I ever need to drain this, that it will drain, and these plates in here could potentially hold coolant in place. And so what I'm going to do is when I cut the disc out, I'm going to drill a tiny little hole in it that will allow air and some very minor amount of liquid to pass through it, so that there's no trapped air bubbles in here, and if I want to drain it out, all the coolant will come out. So that's what I'm about ready to make. This might be interesting. These copper mounting plates, this is what's going to mount the radiator to the wall. And what I want to be able to do is I want this plate to be mounted on this stub right here, and you'll notice that the hole is too small for the stub to go through. What I don't want to do is I don't want to just have that much solder joint attaching the plate to the pipe. I actually want to draw a nipple on this copper right here. So I've drilled a 1/2 inch hole in here. The final diameter needs to be a little over 5/8, which is what the diameter of this pipe is. You can see exactly what it is here. Actually, so yeah, 625 is exactly 5/8. All right, so what I'm going to attempt to do is I'm going to attempt to put this tapered punch through that hole, hoping that the edges of the copper are going to bend down and in, and I'm going to continue doing it far enough until the so let's see what this hole is. 5/8 of an inch, so it's going to, this plate's going to get a little bit deformed in the process, but you can see I formed a little bit of a nipple on there already. Go a little bit farther to see what we've done here. Okay, that's a good tight fit, and it does just fit through there. I'm not going to push it all the way through. You can see the way it is, and that's going to give me a good solder joint. It's going to be very strong because it's got about 2 or 3 times the thickness of the plate. So it does fit there pretty tightly. And just because I know that it probably won't come off in the forward direction, I'm going to push the pipe all the way through. But that's it. We'll dress those up a little bit, clean them up, and we're going to get ready to solder. Okay, well, this is about as close to a miracle as you can come. When I got done with all my soldering, the next step was to clean off the fitting, clean off each of the joints and make sure that they looked like they were full of solder. There's 52 joints in this. I put a PVC valve and a PVC cap on here, and where the air vent's going to be, I put a 1/4 inch air chuck fitting in there. And right now there's 50 psi inside of it, and there are no leaks. The only leaks, there's leaking you can see from right here, which is on the threaded fitting, and there's actually some leaking from right here on the threaded fitting. But of all 52 solder joints, none of them leaked. and this is made with lead-free solder, which makes it even worse. It's luck more than it's skill. I did clean everything fairly thoroughly, knowing that this was going to be a challenge to get all these sealed up, but I'm really surprised that it actually worked out this way. But this is the orientation it's going to be installed in. There's going to be a wall right here, and where these fittings will go through the wall and receive the water will come in here. The coolant will come in and take this path, being forced to take that path by the plates that I installed in there. The valve here is able to regulate the flow somewhat, or to shut it off if you don't want any heat. My suspicion is that because this is in the shower, that if we use this to heat the shower space up, I want to and heat the towels up on it. If you're getting ready to take a shower and this is hot, I would most certainly shut it off, because if you were to brush against this pipe filled with 180-degree coolant, it would be a substantial shock, if not a burn. I think that this will probably cool down in about 5 minutes or so if it's shut off. Anyway, this is done. I'm very happy with it.
Following my nose to the paint fumes. So there's the radiator / towel bar that'll be in the shower, all freshly painted.
Okay, we're coming to you from inside the rebuilt wet bay, which is on the passenger side of the truck. Camera's looking forward, and what you see here is this right here is a hot water manifold, has 4 ports. Right now only using the kitchen sink, lavatory sink, and shower. There's 1 additional port available. Same thing on the back side here for the cold water, and same ports. Okay, these are both fed from above. This red line here is the hot water line coming in from the tank, and you can see all this glob of pipes coming in right here. This is the coolant lines coming from the engine and returning to the engine. So my convention is black lines are return, red lines are supply. So all these lines come through there. There's cold water going out, hot water coming in, cold coolant going out, and hot coolant coming in, which is on the bottom side here. Pretty hard to see. That's on the back wall. In the foreground here, what you can see down on the bottom here are 2 motorized ball valves that provide coolant to, one is to a battery box loop and one is to a gray tank loop. You can see I've just got them short-circuited for right now because I haven't installed the loops in the tanks, but that's what they will be. Back in the corner here, this is the motorized ball valve that opens the coolant for the cabin heat. And if you notice here, all of these lines here from these coolant blocks, they go up through the floor. I have a 4-inch hole in the floor and 3 of my bag boxes that go up through the floor into the cabin. So now on the driver's side here, we have another ball valve here. This is the one that turns the coolant heater on, which is what this is right here. This is a 5 kilowatt Chinese copy of an S-Bar D5 coolant heater. Red is coolant supply, black is coolant return. You can see down here at the bottom is a pump. Diesel fuel comes in through the wall right here into the filter separator, and fuel pump is right here to provide fuel to the coolant heater. Exhaust is here, and the air intake is just above that, and the main power connector is there. Taking a look upward just a little bit, you can see there's a large terminal block right here where all of the control valves and power for all the compartment is on this block. Looking to the rear is the one thing that was in here, is still in here, but is in a different place. This is a reverse osmosis. So we have 2 carbon filters here, a reverse osmosis filter here, a permeate pump, which allows this reverse osmosis system to work in with 40 psi water pressure, and a 1.5 gallon reservoir tank, which feeds in through a remineralizing filter and a carbon filter that go out to the spigot on the kitchen sink. Believe it or not, there's still a big area right in the center here that is going to be used probably for hoses, power cable, whatever, but I finally have good space in here and access to everything. I had the interior lights turned off. You can see them now up on the ceiling there. I put 2 new lights in and a door switch right here which can shut them off. but lots of space in the center there, and very happy with the way things turned out. Okay, the time has finally come. This is the supply hose and this is the return hose for the coolant system. And this is the supply lot side to the heater core. You can see I have a coolant filter installed here, which is about right where the coolant supply needs to go. The coolant return is all the way back under here. It's impossible to see with the camera, but what I'm about ready to do, I'm going to have to take this hose off here, and this steel pipe here comes down a little too far. I need to get this branch fitting in here. In order to do that, I'm going to cut off this pipe a little bit, about an inch, to be able to move it back. I'm fighting the dipstick, the oil fill, but down below the exhaust manifold to get this hose in the right place so that it can lay naturally, which is about like that. This here is actually going to end up on the other side of that oil fill. It's a pretty tight fit, but should not be terribly difficult. What I'm making here are heat spreaders for my hydronic tubing. I've already taken a bunch of pieces of scrap, and essentially this tubing is 5/8 inch outside diameter. And so what I want to be able to do, and its plastic is not very conductive thermally, and it's also not very large in space. So I want to take advantage of a conduction. So this piece of aluminum has been bent so that I can use it to mount it to the floor, but also by the fact that to grip onto the tube, it will use this remaining edge here to be a thermal radiator. I'm going to put a couple of holes in here so I can mount this to the floor. So this will keep it straight, allow it to be thermally conductive. I've only have the flange on one side because I'm actually going to have this up near something else, so I can't actually span in both directions, which would be nice if I could, but it's just a constrained layout. But that's what I'm making. These I've already gone through my scrap box. You can see a piece of scrap, and this is a piece of extremely dirty but very usable offcut that I got from the metal store, and so it's about time to get formed up to. This is about the simplest sheet metal forming you can perform. If you can see these two scribe lines on here, there's one 1/2 inch in and then one that's 1 inch and 60 thousandths in. Both of these bends get made upward, and on the other side is one here at 1 inch and 5/8. This bend gets done first because if I don't do this one first, it becomes complicated. So when you're forming sheet metal, order of operations is important. Okay, so this scribe line is on there. I take about just less than a 90-degree bend. I take it out and I flip it over. And again, I make the inner bend first because I'm going to have to pull it out of the brake to make the next bend. So if I made the outer bend first, if you're a do-it-yourselfer and do any kind of large-scale work, sheet metal brake is definitely a tool that you should have. This brake is a 4-foot brake, and it was purchased used for about $400, and it's probably about a $700 or $800 tool. It's a relatively inexpensive Chinese. Actually, I think this is Taiwanese made, but it works quite well for what I need to do. And it is not difficult to learn nor dangerous to use if you can make all the mistakes you want to make on it and never hurt yourself. I had a little audio malfunction, so this is going to be some voiceover. This is the installation of the coolant tubing swirling back and forth across the floor. You can see the aluminum heat spreaders that collect heat from the tubing and radiate it underneath of the floor. This is both supply and return tubing, so there's actually two pieces of coil coming in here. The supply line comes underneath my right elbow, underneath the kitchen counter, and goes into the heat exchanger underneath the counter. That's the fan. And then it comes back out and swirls back and forth across the floor. So you have the choice of either using the fan convected to push a lot of heat out, or just take the slow heat from the floor by turning the fan off. The placement of these tubes have to be pretty precise because I have all the ductboard supports, and you can see those under my elbow behind me. They're standing up. I've got to time and space all these features underneath the floor so everything can have a space and have a non-interference with other things. This is a small fan coil that's used as a heat exchanger up in the bunk. It's about 5 inches square. It uses a 120 millimeter computer fan. The radiator is actually designed as a liquid cooler for a computer CPU. And the fan which it uses is a high static pressure fan that is specifically designed to work with the small radiator. This is a brass core radiator. A lot of them are aluminum, so this is a much more durable thing. This thing could very easily be hit or kicked and it would hurt you. It's very, very well built. On top of it here is a float air separator, which is an automatic device to help rid air in the system, because this is one of the highest things in the system. That's why it is here. On top of it here, there's also a valve which can throttle the flow of coolant through it, so you can change the amount of heat that it provides. This fan is 25 dB fan, so it's very, very quiet. I wanted something in the bunk that was extremely quiet, and I paid significantly more than the norm for this high static pressure and ultra low quiet fan. It's mounted at an angle so that the air can be drawn in from both sides, and I essentially have the same thing down beneath the kitchen cabinet below for the main living compartment, except it is twice as big. This radiator is just as big as the fan is, and about 1 inch thick, and the one downstairs is twice as big because it has 2 fans behind it. The coolant lines coming and going from this radiator go through the wall right here. The control column, which runs the entire height of the camper, runs right through here. So this happens to be at an angle, cuts right through it. We hang our laundry bag right on it right here, so I haven't put any cover on it, and probably won't. There's just 2 3/8 PEX lines and a 12-volt supply to the fan. The fan is actually thermostatically controlled. The switch on the front of it is not to turn the fan on or off. It's actually to disable it. If for some reason it gets too warm in here and you want to slow down the heat, you can turn the fan off. It's got a 40 degrees centigrade, 100 degree Fahrenheit thermal switch on the back of it, which as soon as the coolant starts flowing through it, it senses the temperature there and it turns the fan on.
If you missed the system layout, I will put a link both above and in the description below so you can take a look at the full design. There's also references of where to actually get the drawings on our blog and a full write-up on the system. So
That's all I got to say about that.
What are you doing just sitting here? Go get busy. Go get busy.
No, I'm getting busy.
What do you mean? We got things to do. We're trying to leave.